Can you see my screen, sir?
Yes. Where is
Yeah,
your downloaded file?
the downloaded file is being downloaded in JSN. I don't know what is this, sir. I don't know how to.
Can you show me the file you show in folder?
When the file is after downloading, I can see only this. It is not showing as a normal zip folder or any file.
You allow me to control? Okay. H. Wait, okay.
This when I changed it into zip folder, I was just changed.
Okay. From what I see here, have you completed your download?
Yes, sir.
Because
In this the type of file is JSON.
the file should be should be around 15 or 17 gigabyte. This one only 1 KB. So I don't think this is the file. Okay, let me check. This one you say you have nothing inside the folder also. Okay, nothing. Okay, let me check. Yeah.
Oh, can control other people's computer. I don't know how.
Yeah.
Oh, I don't know. Have that function.
From file stations. Oh, it takes some time to load. So you can download this, right?
So I did the same thing. Download.
We'll do the same process. Oh, that's great.
Okay. So I download on your desktop.
Maybe
what happens?
we change the type, save as type.
No. This remain this type. Do you save in other type?
Like when I didn't when I found difficulty in downloading, like the file was not showing up, I changed this save as type as WinRAR.
But you need, the file is in a zip file, so you need to save it in zip file.
Yeah.
Then what is your problems?
Can you save now, Dr. Craig?
Earlier it didn't come like this, sir. The type of the file, it came as JSON, JSON.
Your computer have virus or what? I'm not really sure why it happened like this.
Dr. Craig, can you just save? Just try.
Okay, I just save it. But this one, it take very long time to complete because the file is you like 17 GB like this.
Yes.
So it take you a quite long hour to download this. Then have you have any file that is already complete download? No.
Even yesterday it took more than half an hour to download, sir. Each file, like every time when I download, it took so much hours.
Do you mean you download halfway, then it will stop?
No. It will not stop. When I open the folder, like it will be empty. Like when I go for the properties to change, to unclick the unblock thing, to click the unblock thing, in that I saw the type of file as JSON, because in the guidelines in that file, I saw that the file type is compressed zip file. But in my computer, I saw it as JSON file, sir.
Maybe you haven't download complete. You haven't complete the download. You see, it's keep running. 1 point.
Let me check my
something gigabyte.
Let me check my file. I will see what is the size.
I think Marine Wi-Fi network is very slow. It is 29.4.
Let me check my file here.
A few hours.
Okay, let me check. Okay, your file size should be 15.3 GB. The zip file should be 15.3 GB. So after you complete, you will have a zip file, 15.3 GB. Okay.
So,
This is shortcut.
yeah.
15.3. We must download from the website, or we can just share our downloaded version to Maureen. Is same or different?
Different. They got different service pack.
Oh, I
So
see.
the license key is for only SP2 service pack 2 version.
That means every computer has special downloaded package.
No. I mean for tailors, we purchase the SP2 versions.
I mean, can we share the downloaded version to Marine? Then he just download from our shareholder, or she have to go to the same process download from the internet?
Oh, okay. We can download it from somewhere. We can download it from this backup station, and you can upload it to any share drive. Then let your student to download. But usually our share drive, like our personal share drive, we don't have a big space
Like
to
1.1
file like
something.
15.3.
Then Marine, you have to wait out. I think one day I really keep opening your data and your.
Okay.
I don't know whether enough or not.
My students sometimes they're having this problem. The file like they download it halfway, then it will stop.
Oh,
Okay, this because their server is busy. Maybe some other student they download the file, or maybe they are working on their server. So the server will be busy. If your line is slow or your internet speed is weak, you cannot complete with them. So your download maybe it will stop halfway. So to avoid this, maybe I will advise you, maybe you can download during midnight or during the off-peak hour lah.
Oh, okay, sir.
I think for his line, the line speed is very slow. He needs to open a whole day. You see, 18.8.
Yeah.
They 18 megabyte only. 1 gig.
Yeah.
Even 1 second, 1 megabyte. More than that. 2 seconds, 1 megabyte. You can count for it.
Maybe now we are doing the online meeting lah. That's why.
Maybe lah. So Marie, make sure it's download complete. If not, you can't proceed.
Okay, so what I can provide you, I can share you my YouTube link. I can share you some of my exercise that I provide to my student. So maybe from there you can learn how to create the models, the 3D model. You can practice from there.
Yes, sir. Thank you, sir.
This is what I can provide you, but for simulation part, maybe we need to have another sections like online meeting like now, so that I can share with you how to run the simulation, because for my module, for the simulation part, I did not cover in the module, so I don't have the materials for you to learn.
Oh, okay, sir.
Okay. So, Maureen, can you share the table? Maybe you just give him some concept. What's the parameter? What is the purpose of this parameter for his fiber optic? So he had this.
Sir, hope you have seen, sir.
Okay, I roughly know.
Then you go down a bit, Maureen, because Toto Green know this table. So your table, right?
Yes.
Okay. Why steel wire? Why you don't put all of them in one table? Steel wire.
I thought to show it separately because this is steel wire, sir, and this is the
Oh, never mind. Okay.
KFRP.
Screw up, screw up.
And in the because
I want
I didn't find
because I want you to show
percentage.
part one. What is that? Then what is the elastic module? What is the Poisson ratio for part one? Never mind. Okay. Dr. Quick, can you just basically explain what is
Okay.
what is
Maybe
the tensor strength modulus? Why is the steel wire got 4 type here? I don't know.
Huh?
The steel wire why have 4? You also don't know. Never mind. Maybe Dr. Quick can explain this. We get. I think she get it from the material, but I don't know why it have 4. Right?
So, okay, so Dr. Man, maybe I just let me share screen first. Maybe I just show you how is the SolidWorks look like. But can you see what I'm sharing now? Can you see what I'm sharing now?
Not yet. Still the marine screen.
Let me share again. So can you see? Can see what I'm showing now?
Your screen is blue color. No. Yes. Now yes.
Now can see, right?
Yes.
Yes. Yes.
Okay,
Yes,
so
sir.
this is the interface when you install it. After that, you open up, it will show you like this. So this is the welcome page. So actually, if you can call up this page, where here there is a let me check advanced. You see, when you open up, it will show you this home page. Actually, for the SolidWorks, you will have a built-in. I mean, the software itself, you have the tutorial. Maybe you can refer to the tutorial inside here also. You can go to advanced. You see, you can look for tutorial. So you have different tutorial. You can click on tutorial. And where is the tutorial? Let me show tutorials. Let me check how to call up the tutorial. My computer is slow. It takes time to load.
Just another our topic. This SolidWorks also have cracked version. Is it?
Yeah, it also have cracked versions. Let's see. But here it did not. Why it's very slow. Wait a while. I don't think the tutorial showing any information here. So usually when we start, so you can see from here you have part, assembly, and drawing. But I think for your case you don't need the drawing.
Okay.
So maybe you need part and assembly. Okay, so part means you create a single components. So like in your diagram here, you have, I think for your diagram is considered assembly. You have different parts. I mean, you have different wire that is like embedded in a plastic or in a rubber case, right?
Yes.
So I think your is considered assembly. But usually when we start, we are starting with creating part. So what you need to learn, so this one I skip first because I don't have any part. So when you start, usually we start with the part first. You need to create different part. Assembly is after you create a part, then you combine it together, it will become assembly models. So for part, usually we sketch on the plane. We have front, top, right plane. So you sketch on the plane. So here, all the features on the top here, we call it features. Sketch, anything you want to sketch in 2D, we call it sketch features. So from sketch, usually how we build 3D is we sketch a 2D sketch, then we extend the sketch, it will become a 3D object. So for examples, I sketch, so you need to turn on sketch mode. Then you can sketch line, you can sketch shape like slot. This one we call it slot, or you can sketch any shape that you want. So let's say I put a shape. So I see your cables, lovely look something like this. Examples. So you will see when you move your line, you will see a dot line here. The dot line actually help you. It will show you whether you are sketching a straight line or horizontal or vertical line. It will like.
So the dimension show is the in mm or what? The value.
Okay, I forgot to show. So.
Yeah.
Okay, here we have a unit system. So in meters, centimeters, or mm or inch.
Oh, I see. So every value is mm.
Actually, every time when you start, you need to check on the unit.
You have a ruler to measure?
Oh, okay, we haven't insert the dimension. I just roughly sketch a shape.
Okay.
You want to put dimension, we have a smart dimension here. Mean we can put what is the height. And you key in the height. What is the length, for examples. So that's why you need to know all the dimensions. For example, you have some features like this. At least you need to know like what is the dimension here, or you need to know the angle. If you don't know under define, that means your dimension is not, it's not 100% follow the shape. And one is your challenges is how you're going to do measurement for all these dimensions, because your cable is look like so small. Because I see you have some dimension like this, you have a slope here, then the information you need, what is the height or what is the angle or what is the distance here. So this one, you need to figure out how you're going to do measurements. So whatever you sketch in the SolidWorks, it will be exactly similar with your real product. Okay. Usually we say for this part here, what we need to make this define, we need the line here. At least we need to know here also. If you don't have any angle, you can put the angles. If you don't have angles, delete these features, delete this. If you don't have angles, what you need? If you have angles, at least you need to know what is the height here. So that the dimension will be, will be exactly similar as your products. This one just show you an examples. Same also like your hole. Like examples, you have a cable inside. Inside the skin or the rubber skin or what. So or the tubes. So you need to know what is the dimension. Like what is this one is measured in diameters. You need to know what is the diameters, and you need to know what is the positions from left. What is the position maybe from. Maybe the position mean is the center point, measuring from top, or from center point, measuring from bottom. So this is all the dimension you need to figure out. You need to do some measurements on the real product so that you're just able to sketch. Otherwise, you will see all these line, blue in colors mean is underdefined. Underdefined mean you don't have any dimensions. Your sketch can be easily changed. You see the blue color line here. You see a black color line. We call it is fully defined. Mean we have dimensions, or we are clearly stated. You see this line here. If I put a dot here, I try to click and then I try to move it. It cannot move because it's already fully defined. this line here is still underdefined. You see, I can simply move. See, it can change because I don't have dimensions. I don't have any dimension for this. I can simply move. So for a sketch, the most important thing, you need to make sure all the dimensions, you have the dimensions. So it will be fully defined, okay? So let's say I put here 65. Here also it still can move, you see. Because we did not define the angles.
I just want to ask, let's say I define 50 already, right? I just change to 50. So the line according belong to 50, right? It's actually 50 mm, right?
Yep. Whatever you input, it will be exactly perfect.
Oh,
same.
Yes.
Yep. So you see, after I define, you see, when I try to I try to move the line, we cannot move because all is already fully defined. The angle is fixed, everything is fixed. So when everything is fixed, it will become like black in color like this. So if here, you see, I haven't defined.
It's lacking. I hear it. The voice is lacking. The voice is lacking.
Internet.
I don't know. Marine,
maybe internet. I am okay. I'm very clear from here. So this is what I mean by sketch. So when we have sketch, you can turn it. So the basic one, I can show many features you can use. But I think the most common one, we call it extruded boss. From a single sketch, you can extend it like this, extend with different, we call it a V1, extend with different depths. So it will become a 3D object. So let's say this is the cross section for your cable. So it depends on what is the length you're going to study. So you need to check on here, what is the length you're going to study. So maybe you need to study on 500 mm, because we cannot study, because you need to define like your cable is very long, but how long you're going to study? I mean, how long you're going to analysis? We cannot study the whole things like a few meter longs. It can be analyzed, but what is the point? So you need to decide what is the length of the cable that you need to study. We cannot like make it like real. Maybe we can extrude it become a 3 meter long. So I don't think it's possible. So for SolidWorks, under here, you can see from here, we have a different material. You can assign different materials. So if you check under edit materials, the database from the SolidWorks. If you click on single materials here, you will have all data here, like elastic modulus, position ratio, some other like tensile strength, on simulation of thermal properties. So what you need, maybe you need a thermal expansion coefficient, you need a thermal conductivity. So this is what I mean by if you need to run simulation of mechanical properties, at least you need to have elastic modulus or Poisson ratio. Okay, this is minimum. You need these two. But for SolidWorks, I'm curious here. So because for ANSYS, we're able to add materials. If I put a new library here, okay. Let me check how we can add the materials. Configure it. Is it possible to allow us to add the materials? So normally you can assign materials that you can find in database. For example, you change to coppers, you will see the colors is like become like a color of copper. Then if you check on the mass, for example, you can check on the mass. It will tell you, let's say this part is built from coppers. It will tell you how much the mass. If you change to different materials, the mass will change because the density is different. Say if I change to alloy, the colors will become like alloy, and the mass will be different. And for simulations, here you will have a simulations. If you're using SolidWorks, SolidWorks have a built-in simulations. But I think before you use simulations, you need to go here, SolidWorks add-on. You need to add on SolidWorks simulation if you are first time you're using simulation. Because by default, the simulations, by default setting, the simulations features is not appear on the top here. You need to go SolidWorks add-on. So you see SolidWorks, they have different add-on features. So simulation is under one of the features. So you need to turn on. Then when you after turn on, you have a SolidWorks simulation here. Then you need to run new study. So we can simulate the materials in different conditions. For mechanicals, we usually study on static. We call it static. Some like you can study for thermals. Yeah. So let's say we click on static. Then here, all the features is already turned on. So the first thing you need to apply what is the materials. So I'm still thinking whether I can create
material.
Let me think. Because usually for the class, we just, I mean for SolidWorks, I did not included this in the simulation. For Taylor's student learn simulation, they use other software. They're using ANSYS. This one SolidWorks, I don't think is customized materials. New category. Okay, let me check on new category. Maybe I have plastic. Let me check. New materials. Yeah, it's allowed me to put a new material. Maybe I have ABC plastic. So you can see on my plastic here, I put under plastic. I need to insert what is the modulus here. In red color here, density is depend. If you want to look for the mass, then you need to insert the correct density because the calculation, they will calculate based on the input. So if you want to look for like safety factors, so here you need to insert the value here. So this is how you insert a new material here. So I just put it as default here. The material where yield strength, you see, it's not able to run. I just put maybe 80, 6. So E is mean 10 power of. Okay, let me check. Okay,
Maureen, can you hear me clearly? Maureen? Can you hear,
Yes.
can you hear the sound clearly?
Here.
Oh, yes. Never mind, because it's okay.
Okay. So the first thing you say, you need to apply a materials, mean you need to have some material properties. So I hope you understand. If you create a new materials, you need to run for static structures. You need like elastic modulus, Poisson ratio, yield strength, and density. Density, I don't think is necessary unless you need to look for the mass. But I know that you need to know yield strength. Okay, then you need to understand what is mean by this one, a fixed support. They have different kind of support. So when we simulate design, I mean the products, you need to know what is what we call it the boundary conditions. What is the conditions? Let's say I give you different product, yeah. Because this one I'm not really sure what is your boundary condition. So I also don't know how to set the boundary condition or the features here. So I give you others examples. I give you more simple. This one is I prepare for my class. Okay, this one is the bracket. This one is the bracket. So let's say I need to know, let me explain to you first. So this bracket, this one is the screw hole. Okay, this one is a screw hole. On the top and bottom is screw hole. So the screw hole, usually we install screw on the wall, maybe on the ceiling, maybe on the floor. And the bracket here, the big hole here, maybe I'm going to hang something, hang a heavy object. And this heavy object, maybe like, I need to know. I'm not sure whether my bracket that I designed, it can withstand 10 kg or not. I don't know whether it can withstand 10 kg or not. So what I'm going to do, I will create this 3D, the 3D component here. I go to study. I go to create a static here. Now first, I need to know what is the materials for this bracket. So maybe maybe I use this steel, this type of steel 1020, low carbon steel. So I just apply and I close. You will see from here that I select now AISI 1020. So I have a materials. So if you have a materials, means the modulus of this, and we have a yield strength also. Okay, Then fixed support. Okay, here I will apply a fixed geometry. And this fixed geometry, I will select the inner face here. Okay, the fixed geometry means the location or the screw hole, it will permanently like stick on the wall. Then it won't change. The positions, the shape, it won't change. Because I assume I already put a screw on that and it fixed to the wall, it won't move. It won't move. We fix to, so that's why this particular location I highlight here, I put it as fixed geometry. Means it will permanently fix. Then it will be permanently fixed. See, it will permanently fix. Then after we know what is the boundary conditions, then we need to know what kind of load. So it can be torsion, it can be pressures. Yeah, you can see from here. Now I need to know how much force that if I put on top, I hang it somewhere here. I hang on here. Yeah, whether it can withstand. So I put a force, I hang, then the touching surface, it will be hang on somewhere here. Okay, maybe the force that apply, it will hang on the particular location here. So maybe you can click on the face. Then you need to check on the direction of the force you can select. I can take this as a reference. See, I click on the edge here as a reference of the direction. So maybe you can put a reverse directions. It's the direction of the force. If I hang something, so that means the direction is pointing downward. So you need to know how much. So let's say if you have a 10 kg load, mean how much Newton you need? 98.1. Okay, I hope you understand. If I want to hang something with 9 kg, because 1 kg equal to 9.81 Newton. So if I need to know whether this bracket can withstand 10 kg of load or not, so I will apply the force. Okay, then I click confirm. The second thing is about the mass. Okay, now you see from here, the model is look like this. If you click on mass, okay, first I create the mass first. So I just put default settings. The mass is when the simulation, when you do calculation, they will break your models into shape here. This we call it a mass, elements. You will break it into small parts like this, a triangles elements. Okay, so it will do a calculations based on these elements. It will do some influence your result also. You can see this one is by default system. We can create mass. You can put the mass is very big in size, very crowded. Okay, so for mass sizing, if your mass sizing is getting smaller, the numbers of this shape, you are getting more. When you're getting more, mean your computer need to do more calculations. And usually your result, it can, but you also need to check because if you keep increasing the number of elements, you keep making the mass size become fine and very fine, because sometimes the result that you obtain is not significantly changed. They do not give you any you. Okay, now we run a mass like this first. I just put the mass. So the mass is somewhere is cross. You see, you can just now. Yep. So after you set a features, you set a load is simulation. So when you say now it's running, you see it's very fast, it's very quick. You see, when I put a mass size is very big, the calculation is done very fast. And this is the result. We will check on the wound misses stress and the displacement. Displacement is how much the displacement happen on the particular locations, and the strain. Okay, you can check for other result. Let's say you need to look for, or I can include the result for safety and effect. Here, plot.
So I can't hear you. Are you speaking or? Sir?
Okay, I accidentally mute my computers. Okay, can you hear now? Okay, the
Yes,
value
sir.
here usually give you a value for maximum to a minimum. So for stress, usually for minimum stress, is not our focus. We usually will focus on what happened on the maximum. It's around like 3.5, 6, 10 power of 8. So if we change this to, let me edit the definitions. We change to megapascal. So your materials is around 300 something megapascal. Now maximum stress happen here, happen at the particular location here.
Okay.
Then the software, it won't tell you whether this material it will fail or it will break. You can see from here, the yield strength is the maximum strength of the materials. It can withstand before it undergo the plastic deformations. It can undergo a permanent change. So what we need to make sure your design it won't fail. We need to look for the maximum stress here.
Okay.
The maximum here, we have 1790 here. You need to make
Yes.
this is the minimum, but it depends. If you have a requirement on the safety factors, then it will be different. If you need safety factors, if you need the safety factor is 2, then I don't think this will fulfill. Means the maximum stress you need, you need to target is at least half of your yield strength if your safety factor is 2. I want to try to show you how can call up put a safety factor here. Okay, we check based on maximum. Okay, then we put confirm. Yeah, okay. Then you can check here. So for safety factor, usually we check for, though you can see from here, all the locations, most of the location, they have a safety factors 1.64. Yeah, 1.964. So if let's say your product or your design, the safety factor requirement is 1.2, that means definitely your design here is certified. We can use. But if let's say your client need this safety factor is value of 2, that means it's not achieved. But this material won't fail. Just you cannot fulfill the requirement of the factor of safety. Okay, I can show you so you can see from here. That's now what we check. You can see solver message. Okay, this one we use a very big size of elements. Number of elements is around 1,500. You can refine the mass. Sorry, not this one. You can refine the mass. You can refine the mass. Confirm. We can make this become fine. Then I click confirm. You will see the time. Every time you change on the mass size, the result you need to recalculate. It will pop up the symbol like this. We check on, you see, hey, the number of, I think I haven't solved. Let me run this. It's quite fast also. Maybe my models is quite simple. The dimension is quite, here the result is changed. Just now the maximum is around 1.7 something. Now it's increased to 1.9. The result, it may influence, it will change because of your mass. Yeah, it will change because of your mass. Then the safety factor also, just now is 1.9. Now it become 1.8 because the mass, we can check on the solver masses. You can see from here, the number of elements is keep like increasing 10 times more. Is it? Because we're making the size become smaller. So the number of elements, it will increase. So, okay. Just now I apply the force is I increase the size, increase the weight. Maybe I put it like 300 newtons. So it's around 300 kg. So I run again. This one, I think there's some error here. Just let it run. You can see from here, your yield strength is around like 351 megapascal, but the maximum strength, the maximum here is now is like 500 something. But you will see from the visual result here, it won't show you this blanket. It will break into 2 pieces. But theoretically, the applied stress that happened on the body of this blanket is already exceeds the yield strength of the materials. Theoretically, this blanket should bend and deform permanently, or it will break into 2 pieces. But you can see from here simulation, it won't show you. It won't show you whether it will break or not. we need to decide based on the data that we get, like the simulation result, what is the maximum stress is subjected to this, the material properties. We're going to decide whether it will fail or not. So do you understand?
Yes, sir.
Yeah. So this is, last time I discussed this with Dr. Man. I will tell Dr. Man the software, it won't tell you whether this thing, it will break into two pieces or not, it will fail or not, but based on the data, we need to decide by ourselves. That's why you need
So
some
we interpret ourselves.
yeah, you need to like, analyze by yourself.
One question, let's say I have two type of material in one figure. So how we analyze the legend and at the right hand side? So will it show two yield strength or what? Now I know it's one material in one yield strength.
That one will be, I try to find something, yeah, I try to look for.
Maybe you can just show the main
material, right?
Main material, the support.
I need to, I'm not really sure I got a sample or not. So you have two different materials. So I just roughly sketch. So let's say I have the first materials, maybe I extend this.
So
Wait, let me create some part first. This is what I mean by assembly models. Like let's say I assign the material, then you know what is this? Where's my materials? You assign the material. Let's say this, I make this from the rubbers. And these materials, I make this from coppers. Okay. This one, we call it assembly. Mean I have two parts. The middle part here, the cylinder here is a part. So here is the part 3. Just now I create. Part 4 is the outside here. So I can insert two materials. You see, this is rubber.
So could I ask you, can we import the library for the material? By default, for example, someone have say that
let me run the simulation here. Let's say for the part here, you see, you have different part. So here, same also, you need to apply materials. So if you have new material, means you need to under here. So you see, just now I create a material ABC. ABC still here. So in the database, the default materials, there is a material from the database. If you need to create, maybe you can create under a customized materials. Then under here, under here, you can add new materials. So this is the new material just now when I added.
So
Okay.
all the material we have to define ourselves. Right? What I mean is possible someone has developed the material already, the information, then we just import
You just key
some well-known
so
material.
Dr. Man, you can key in from here. I mean, you can, if you have the data, you get it from somewhere.
Let's say I don't have the data. I just know that it's very well known. Let's say fiber optic, the optic is used the glass, right? So it's very well known material. But I don't know the elastic modulus. I don't know the use strength. Is the SOLIDWORKs have the library?
You see, but here you can here is the generic glass fiber. But you have different type of glass fiber. And which one is appropriate one? If you can define, then is but this one is also incomplete. You see, glass fiber, they don't have the mechanical properties. Don't have the Poisson ratio. It's incomplete. If you really want to run on the simulation, you still need to key in the information in this table.
For the red color one, is compulsory value, or why you use the red color?
Yes, it's compulsory if you want to run for static structures. I mean static analysis.
So we should know the value.
Yeah. You can simply put in the value, but end out the results show you it's not something it can represent your real product.
Yeah. Let's say you want to proof of concept
for you.
Let's say you want to proof of concept. Two different design. So the second design is better than say first one.
But
so
we need, because if we put some value is not appropriate, and now the outcome that you want maybe is not something is close to the real one. So it will be no point for you. Maybe what you design here is in SolidWorks is show you the result. Wow, the strength is perfect, it's very high. But in the reality, when you produce, maybe it's not like that. It's something is very low mechanical properties. So it will be, for me, it's like no point.
One question now, why the generic class fiber they don't put in the elastic modulus?
This one I'm not sure, but maybe this one they put in. They don't have a mess. They don't have the result. I also don't know why.
Yeah, I thought if someone actually they have some standard value for the A class fiber or G class fiber, they can file in internet or somewhere else. They already have defined some. Maybe it's not close to our fiber, but it's at least similar, or then we just use at least it's out of the range. It's in the range, and at least will be okay.
At least need to be very close.
Closer
the closer the properties you can find, I mean your result will be more reliable. It will be more practical, your result that you get.
What I mean is I want to simulate, let's say a fiber. I just put a elastic modulus that value is close to the new fiber, last fiber value. I no need to just have same as my actual fiber. I just want to put a value is same group, same value, because that's impossible for me to get the value for my fiber in the lab. So I just go to internet. Okay, this fiber is this elastic modulus. I just put in the value for my simulation. Then I think it should be, I know it's not the best, but at least the elastic modulus, this value is fiber, right? Not steel, right? So it's still acceptable, right? In terms of compare the concept of the design, the structure. I add one more steel, then I can say that the design B, one more steel is better than original design.
If if the variable input is the design, then that is possible. Because your material oil will be same. Design. You can do a comparison. That one
It's my.
That one is possible.
This is my idea, because usually you want to find the actual value of the company product. It's difficult. Sometimes they do measure the elastic modulus also. That's why Marine can't find the value. Even
so the one you need to set a goal. I mean, you need to set a target. What kind of properties you're going to achieve, or what kind of strength. I mean, you need to set a goal what you need, so that you can set the variables. You can do a different type of analysis to check whether all this design can be achieved your goal or not.
It means, let's say, what is the maximum force, external force applied, and what is the yield strength, minimum yield strength, or maximum yield strength.
Yeah, just now as what I show you the example that just now I showed to you, like the bracket here.
Yeah.
The idea is similar. Like I designed this, so I will try to apply stress whether this can withstand the strength, because my goal is I need to know whether this bracket can withstand 10 kg or not. So if now let's say I know it can withstand 10 kg, but maybe whether it's over designed or not, because sometimes when we design, maybe the steel, just now you see the plate here. So the thickness of my plate here, I use 3 mm. So maybe I put 3 mm, I put 10 kg of load. Just now when we do analysis, the maximum stress is like 170 something. But my materials can withstand about 300 something megapascal. So maybe I think my material it already can withstand 10 kg of load without failures. But maybe I would think that, is it over designed? Because my material it can withstand 300 megapascal, but the subjected load is like around 170. So it still can, it won't fail. So maybe I would think that maybe I want to save the cost. I can reduce the size of the thickness. So this is some of the idea you can consider. Or maybe you want to make this bracket become stronger. You can add somewhere thicker, or you can add a support at the bottoms. So all this is actually simulations help you to do a decision, make a decision. Let me see whether I have others can share. Okay, let me share this. Okay. Okay, can you see what I share?
Yes, I can see.
Okay, so for example, we have different design. Okay, the support here, this one we create like a frame for our tables. So we are not sure the design, like if you put 30 degree, can withstand hundreds, pound or not, or 60 degree is better. We don't know. So without any real prototype, it's not tested. Who's going to tell us which design is better? So we run on simulations, like the simulation I showed you just now. So we will decide based on, like, for example, the safety factors. So the higher the safety factors will be the better. So from here we know that this design of 60 degree is the best. Then, for example, maybe we already fixed, we know that we want to design something with this design, with the angle of the, we call it the support here, 60 degree. But what materials is suitable, and what is the cost, and what is the tube size? Because in the market, you buy the metal tube, they got different thickness of size. They got like 0.8 mm thickness, 1 mm thickness, 1.2 mm thickness. We don't know. So what we can do, we run on simulation also. So we check on the safety factors. So and now you can look for this different materials. It will show you different result, like different safety factors. Then some software, they have a price. You can check on the price, but some of the price you need to put the input for material price. You can put as an input. So you will run, because the software we're able to calculate the mass. So if let's say in the market, carbon steel 1 kg is how much ringgit or how much USD, then from the mass you're able to calculate for the price so you can see from here, this is how we do decisions based on the simulation if you have different design. And this is another scenario. Let's say you have bracket here. So which design is good? It's a double, you have the double support here, your single support, and how is the layout? You have a 4 bolt, 3 bolt. Which one is the best? If we need safety factor, like minimum, we need 2 or above. So for example, is for your case, maybe you have different layout, different design of your the fiber optics. So this, you need to run all this simulation to decide which one is the best. But you need to set a goal. A goal means, like, let's say for this example here, the goal is I need to make sure my safety factor is at least 2 or and above. So you have a goal. So the result come out, let's say you can see B and C design is not fulfill the safety factors. So definitely these two design is out. Then we have A and B, A and D. A and D, they will have safety factors. So as we know, the higher safety factor is the best. So we know which one is the best, which one is the second, and which one is not fulfill your goal. So this is what I mean. So far, any questions?
So quick, I ask you, the safety factor is in what unit? I know use strength after certain use strength.
Safety factor is the ratio between the applied your yield stress divided by your applied stress.
Oh, yield strength divided by applied stress.
You can find it online. What is the definition?
Oh, I see, I see.
And the safety factors is based on your applications. Different application, the need of the safety factor will be different. So it depends on the application. This one, you need to look for this. Look for it.
Okay. So they decide more than at least 2, at least 3.
This one depends on the applications. Because how they decide this, they will check on the risk, like if this material is failed, I mean how serious of the accident or the cause it will happen. For example, the safety factors they need for the lift, cable for the lift. So as I know, they need safety factor of 40.
40. Oh, I see.
Yes, because you see lift, if the cable is failed, it will cause human life. Yeah, we will definitely get inside the lift. That's why the cost of the failures, it will be very high. So that's why they will set the safety factors very high.
See.
So my advice is my advice for this, maybe the first thing you need to set what is your target, what is the goal for your design, what you're going to achieve. Then second, maybe you need to have your dimensions. You need to find all the dimensions for your cables. What is the diameters? Okay. What is the length? What is, if involve angle, then what is the angle? This one you need to figure out how to look for the dimensions. And then for simulation part, you need to have the properties that I show you just now. Elastic modulus, position ratio, yield stress, yield strength or yield stress. And for the mass, for the density, I think it won't be too difficult, because the density for the materials, like if the material is glass, the density, it will be around there. It won't be too much difference. So if you put a wrong value for the density also, it won't affect the result for the simulations, especially for the stress. Because the stress, the calculation did not involve the density. But the mass of the material, it will definitely influenced by the density.
Sorry, you mean the mass value will not affect the use strength or use the simulation? Oh.
Because the formulation did not take any numbers from the density.
Oh, so mass and mass density is same thing in your simulation? Is it or different thing?
Okay, the mass, how the SolidWorks calculate for the mass, they were, because, okay, when we sketch, let me go back to my SolidWorks.
Mass is how many kg of the material, gram.
Yeah, let me go back to my SolidWorks. Okay, from here, you will see here, when we sketch everything in 3D, the software, it can detect the volume.
Oh, well, yes.
It's able to detect the volume. And then it will take the value for volume, multiply with the density, so it will get the mass.
Oh, yes.
So this is how SolidWorks calculate the mass
and density.
Because your models, when you sketch this, the volume always fixed. No matter what material I change, you see I change to ABS plastic here. You see the volume remains the same, but the mass become different because it's influenced by the density. If I change to steel, you will see the mass, it will be different. Mass, it will change, but the volume always remain the same. So the SolidWorks, how it calculates for the mass is based on the volume and the density of the materials.
But density of the material we have to key in is a mass value, right?
Okay, if you're not looking for the mass, you put the wrong value also, never mind.
Oh, the density will not affect the maximum use strength or what, right?
No, no, no. It won't even affect.
I think different material.
Because for the calculations, if you look for the material properties, the stress is the force divided by the area. So the input, we don't have a density.
Oh, force divided
So it
area.
doesn't matter. So it doesn't matter.
Okay. Yeah, just. Well, so how about the two material one you want to show us, right? Join together. You want to show example two material combined together and then you simulate.
Oh, just now.
Just not that.
I mean, same also. The simulation will
Part
be
one part.
will be the similars. You see, I have two materials. I run a static. Okay, this one, I think I delete this. I already have a static one here. So you have two materials. The method is similar. I put here this end here. I put it fixed. Maybe the other end, I want to do a bending. So I will put a load here, force. Maybe I force on the edge here. Then I check the directions. I take these directions. Okay, pointing downward. Or maybe I put a value of 100 Newton. Then run on the mesh. This one is default. So it automatically will generate mesh. It automatically will generate mesh. Then you just run for the result.
Oh, something.
Yeah, you can see because you have two material. You have two material. So two materials, they are modular elasticity different. So they will deform differently. You see the outer case here, where I put a rubber, it will be soft copper. I think I put a material is harder. So you can see the outer here, it deform more than the inner here.
They'll collide with each other.
Yeah, the way it's deformed is different. So the result actually show you just different.
The force is from the top, right?
So maybe when you run on your simulation, maybe you'll find out your finding will look like this. Maybe the outer form differently if you compare with the inner part. But it won't tell you whether your fiber optic it will break or not. You only can determine from here. You can only determine from the maximum stress.
So this one is outer part, right? The maximums, the label, the agent at the right hand side is outer part material, right?
Notaman, I'm not clear.
Yeah, I mean that the simulation that you show here, right? The right hand side, the region, right, is shown for the outer part material.
Yeah. Yeah.
Yeah.
It will show what is the maximum stress will happen here.
That means we can't know that, let's say the inside the circle is a fiber optic. We don't know what is the maximum stress inside the fiber optic. We only can know whether the cover will break or not. So we just can simulate the outside one will break or not.
And one more thing, this one, the connection of the component, we need to set, because you have two components, so you need to know what is the connection between them. So if these two components is not, what we call it, it's not bonded, it's not like welded, so you need to know what is the friction between them. This one, the contact you need to fix. Or if these two materials, they have a gap between them, you need to know what is the current. So this is a difficult part in these two materials. This is a difficult part here. Let's say I put here, and what is my components? Maybe I put here the contact. So under connection here, you need to define what is the friction between these two materials, because now you have two materials involved.
I see. Yeah.
So it will be slightly different if you run on assembly models, where the assembly model have different material, different component in one single body. So you need to decide on what is the connection, or what we call it as a contact between two components. While we are waiting, so far, Do you still have any question on this?
Do you have any question? I think,
Dr. Man, not clear.
Maureen, do you have any question?
Not clear, Dr. Man. Dr.
Okay,
Man,
I mean, Maureen, do you have any question? So far, I think I asked also no point already. I think we have to do it, and if you have any problem, only can we can ask something like that or consult you later. But generally, you give us a very good introduction.
at least for today, you have a rough figures. You know that, oh, what is a simulation about? At least you have some idea. You have some image in your mind. You have some understanding on this.
Yes, yes,
And
sir.
I think what you need is you need to make sure you have the software first. You need to solve this problem first. First, you download the SolidWorks. If you find out some problem for installation, you can look for me.
Yes.
But the first thing you need to make sure the file is completely
Okay,
downloaded.
sir.
The file size is 15.3 GB. If incomplete download, maybe when you open up, some file is missing, you cannot do anything also.
Okay, sir.
Then after you get the SolidWorks, because you are first time using SolidWorks, you need some time to practice how to use these features. The first thing is how to use the SolidWorks. So for that one, what I can provide you, I will share the links to you
Okay.
and share you some tutorial questions for my class. So maybe you can learn from there.
Okay.
So for the SolidWorks things, maybe you just drop me an email. I just send you the materials. I just share you the materials. So Dr. Man, still have anything?
I think no more again. We just what you said. Maureen had to do her part before we can meet you again to consult you again. Thank you for your support.
Okay.
Very good sharing. Thank you so much.
Okay, welcome.
Thank you so much, sir.
But Maureen, can you stay here for a while?
Okay.
I want to give you some suggestion for your table. Dr. Kui, you can go now if you want.
Okay.
Thank you, Dr. Kui. Okay, Maureen, can you share your screen? May I control your screen for a while? For the table, I want to help you to define your table. Okay, could you share your screen?